Alright, so we're still doing antiderivatives or integration. This time it's going to be involving trig identities. Now you've already learned a bunch of trig identities. We're going to need to learn some more. Now this particular video is all about finding antiderivatives of even powers of sin x and cos x. So that's sine squared x, or sine to the 4x, or sine to the 6x, or something like that. Alright, so 3 trig identities. Alright, so here's 3 useful trig identities that we can use for this even power stuff. Now you might want to go away and prove, using your existing trig identities, the ones that you've already learned, that these are true. That's probably, perhaps not now, but a good use of your time later on, maybe leading into the exam, practicing proving certain trig identities using trig identities you already know. You can always shoot your textbook if you want to see how that's done. Let's look at an example of an antiderivative of an even power. Alright, so we're doing the integral of sine squared x on 2. Now, look at your first identity here. It's sine squared ax. Now, this is sine squared ax2. It's just that the a is a half. So it's like sine squared half x. So we can rewrite this using that first identity. So we can rewrite it as 1/2, 1 minus cos 2 times 1/2, because the a is 1/2. So 2 times 1/2 is just 1, and then the x. Alright, so half times 1 minus cos x. And we can start integrating that. So there's our first step using one of those trig identities. From there, it's really straightforward. This is a factor here, so we can just pull that out. And now we're finding the integral of 1 minus cos x. Now I don't need the brackets anymore because those brackets are being multiplied by half. Now we can just, I should be doing with respect to x here, shouldn't I? With respect to x. With respect to x. Now from here we can just anti-differentiate that by rule. So we've got 1/2, and this is x, and the antiderivative of that is sine x. I think it's positive sine x, negative sine x. And then we're going to need a plus c on the end. Now you can just kind of bring that factor back. So we can do x over 2 minus 1/2 sine x plus c. Alright, so a little bit complicated there, but you've got this, you've turned it into your trig identity, pulled the factor out, and then you've been able to use your rules there. You should be able to anti-differentiate cos x quite quickly, and you should also be able to anti-differentiate the number 1 quite easily as well. Alright, so here's our second question here. The integral of 2 cos squared x on 4 with respect to x. So if I'm finding the integral of that, the first step is to notice that this cos squared business can be related to our second identity here. Now, just be careful with how you work here. It's not cos squared ax, it's 2 cos squared ax. So we're still going to need that 2 out the front, and then it's going to be 2 times 1/2, 1 plus cos, and then it's 2, and a is 1 on 4. So 2 times 1 on 4 is 2 on 4, which is 1/2 cos x on 2. So it's 1/2 x on 2. Alright, so there's a good first step there. Now 2 times 1/2 is just going to be 1. So now I have 1 plus cos x on 2 with respect to x, with respect to x. And really simple from here, you're just anti-differentiating by rule. So that 1 becomes x. This cos x on 2, that comes out the front here. That's going to be plus 2 sine x on 2 plus c. Alright, just be careful here. That 2, remember you've got 1/2 there, and when you're anti-differentiating, that comes out and it's divided by 1/2, which is the same as multiplying by 2. Alright, so third example here, pretty good guess that it's going to use our third identity here. let's take a look at the integral for sine squared x on 2, cos squared x on 2 with respect to x. Now the hint is we're using the third identity, which is sine of something times cos of something equals this. So it's not immediately apparent that it's there, I suppose, because it says sine squared times cos squared. But of course, you could rewrite that, because that's just sine times cos times cos. So I'm going to rewrite this as 4 sine x on 2 times cos x on 2. So that's 1 each, because it was sine squared, so sine times sine, cos times cos. And if I square that, so I'm doing sine times cos times sine times cos. Same deal as what's happening over there with respect to x. Now, pretty easy to guess, I suppose, that we're going to be able to use this identity. So it's the integral of 4. All of that gets replaced with this identity. So it's 4 1/2 sine 2. I'll just put a bracket here so you can see what's happening. It's sine 2 times whatever the a is, so 2 times 1/2 x. And I can close the bracket, and all of that is being squared with respect to x. Now that's silly, obviously. 2 times 1/2, that's just going to be x. We'll move everything forward a little bit. So now we have sine x squared with respect to x. Bit squeaky. Alright, now, what are we going to do with this? If I square this, will I square that? Let me think. Alright, could have gone 1-2 directions there. I think the best way to do this is to square all of this. Now if I do that, it's going to be 1/2 squared, which is 1/4. So I have 4 1/4 sine squared x. Still with respect to x, we're still integrating. Now that's 4 times 1/4, so it's just the integral of sine squared x with respect to x. Now you don't know how to find the integral of sine squared x, but you do know that sine squared x is the same as this. So we can say that now we're finding the integral of 1/2 1 minus cos 2x with respect to x. So now, of course, that half can come out. This is very similar to a question we've already done in this video. Integral 1 minus cos 2x with respect to x. And now I'm just going to do that one, just finish it off here, equals, now the integral of 1, so it's going to be 1/2 times, the integral of 1 is x, the integral of cos 2x is 1/2 sine x, and then plus the c, and then you're going to have x over 2 minus 1/4 sine x. I lost my 2 somewhere. 2x plus c. But that last step there, that's very, very similar to the very first question I did in this video.